Welcome to the deep dive. Today, we're cutting through the noise on a really fascinating event. The very unusual and very early collapse of the polar vortex.
That's right.
And we're going to look at what that signals for our weather in December 2025. The main event here is something called a Major Sudden Stratospheric Warming, or SSW. And your sources are saying it's set to peak right around November 26th. What's so amazing is the timing a November SSW has, only happened twice since 1958?
Only twice. It's incredibly rare. And, this is the definition of a textbook major SSW, which is why meteorologists are really paying attention.
Okay, so what is that exactly?
So we're talking about an extreme, very rapid temperature spike way, way up in the polar stratosphere. I mean, it can jump 33 degrees Celsius in just a few days.
Wow.
And that warming is so powerful, it basically forces the high-altitude jet stream, this massive circulating wind, to just stop and completely reverse direction.
So if the polar vortex is like a wall holding the cold air in, the SSW just smashes a hole in it.
That's a perfect analogy.
But, we've seen SSW events before, and they don't always lead to this deep freeze on the ground. So why is the forecast confidence so high for this one?
That is the million-dollar question. And the difference this time is what the sources are calling a triple coupling synergy.
Triple coupling?
Yeah, it's not an isolated event. The SSW is happening at the same time as two other big climate drivers. A background weak La Niña, and, this is the critical part, an active Madden-Julian Oscillation in Phase 6.
Okay, let's unpack that MJO piece. What does Phase 6 actually do here?
Well, think of the MJO as this traveling wave of thunderstorms in the tropics. When that wave hits Phase 6, it sends this huge pulse of energy upwards into the stratosphere.
Right.
It's like getting a giant, perfectly timed push on a playground swing. It ensures the collapse of the vortex is total and that the effects make it all the way down to the surface. It really maximizes the cold air delivery.
Which brings us to timing. This isn't an instant thing, right? The cold takes a while to get down here.
Exactly. There's a consistent lag. The response at the surface, where we live, happens about 10 to 30 days after the peak warming, way up high.
So with the SSW peaking in late November, that points the finger directly at early and mid-December for the really big impacts.
It does. And the final piece of the puzzle, the steering pattern, is this huge high-pressure block that's forecast to just anchor itself over the Beaufort Sea.
Near Alaska and Western Canada.
Right. And that block forces the whole pattern into what we call a negative Arctic oscillation.
So what does that Beaufort Sea block mean for our weather on the ground?
It means the door to the Arctic is propped wide open, but in a really specific way. The block acts like a dam, a stationary pressure dam.
Okay.
It stops the cold air from just spinning around the pole and instead channels it almost exclusively straight south into North America.
So you get this huge split in the weather pattern across the continent.
A massive split.
Yeah.
The sources show really high certainty for way below normal temperatures and more snow all across the northern tier of the U.S. Think Great Lakes, Northern Plains.
In Canada, too, I'd imagine.
Oh, absolutely. Central and Eastern Canada are looking at a very high chance for a cold and snowy holiday season.
But there's a flip side.
There is. Thanks to that underlying La Niña, the southern tier of the U.S., the Gulf Coast, is favored to see widespread warmth and drier conditions.
And what about Europe? Do they get in on this?
They get an initial shot of cold, yeah, but it won't last. That Beaufort Sea block tends to lock the really deep, persistent cold over here, over North America. So Europe likely goes back to near or even above normal temperatures as December goes on.
So to sum it all up for you, the listener, the evidence really points overwhelmingly to a long, aggressive cold pattern for the northern half of North America for pretty much all of December 2025.
It's a powerful confluence of factors. But I'll leave you with this final provocative thought to chew on.
Okay.
All of this high certainty, this predictability for extreme cold, it plummets after January 1st, 2026.
Why is that?
Because that big push from the stratosphere, from the SSW, it just fades away. The atmosphere then goes back to being driven by the much more chaotic weak La Niña. So you have much higher risk of, say, a sudden midwinter thaw. This is a powerful December story, but it's not necessarily a whole winter story.